Okay, let's review subtracting mixed numbers with borrowing. Let's start with the problem we had on last night's assignment with number 12. First thing, when you look at this particular problem, you'll notice that we do have some positive and negative signs. We've got some negatives here. So anytime we have negatives and we have a subtraction, we need to remember that we've got to leave change opposite. We've got to LCO the problem. Leave the first number alone, change subtraction to addition, next number to its opposite. Then we go back to our regular integer rules. Even though these aren't integers, they still follow the same rules as integers. Well, since our signs are different, what we're going to do is we're going to subtract our numbers. So we take the number that is farthest from 0, the 8.5, and we're going to subtract 5 2/3 from that. So the integer rules, all they do is they tell us what we need to do. And then we use our fraction rules in order to do that. So we're going to start with the 8.5, and we're going to subtract the 5 2/3 from that. Well, in order to do that, we need to find common denominators. So the first thing we do is we rewrite our problem so that I can find that common denominator. So with 2 and 3, our denominators, we know our common denominator will be 6. Okay. So we ask ourselves, how did I go from 2 to 6? I multiplied by 3. I do the same thing to the top. So 1 times 3 is 3. How did I go from 3 to 6? I multiplied by 2. So 2 times 2 gives us 4. Now this poses a problem. We've got 3/6, take away 4/6. Well, we can't do that because this fraction's not big enough to subtract 4/6 from it. So just like in any other math problem, we have to borrow. So we're going to borrow from this 8 right here. So this 8 becomes a 7. Well, the number that I borrowed needs to be in the form of a fraction. It's going to be equal to 1, and it has to have a 6 as the denominator because I've got to maintain common denominators. Well, the number that I need to put on the top then for this fraction to be equivalent to 1 is 6. Well, we know the 7 and 6 over 6 is equal to the original 8, but I still have this 3/6 to deal with. So we're going to add 3/6 onto it to account for that. So 7 and 6 over 6, which is our original 8, plus 3/6 gives us our entire 8 and 3/6. But what that does is that allows us to put these two fractions together, and it gives us 7 and 9 over 6, which is, and the reason why we were having to borrow in the first place is this fraction here wasn't big enough for me to subtract this one from it. So when I borrowed, I made this fraction bigger or big enough so that I can subtract the 4/6 from it. So really the trick that you see is when you borrow 1, which in this case was 6 over 6. We added the 3 over 6 to that. The trick to borrowing is you just take the denominator and the numerator of the original fraction and just add those together. And that will always find you your numerator. And so now that I've found this, we can now subtract the 5 and 4/6 from it. So 9/6 take away 4/6 gives us 5 over 6. And then 7 take away 5 gives us 2. So let's try a couple more just to see if you can see if you get this. So we've got 7 1/3 minus 4 3/5. Well, again, I kind of like them written up and down. Makes it a little easier to deal with and a little easier to see. And we're going to subtract these. So the first thing we do is we find a common denominator. So I rewrite so that I can find the common denominator. Okay, I've got a 3 and a 5. Well, the first number that comes to mind that they have in common is a 15. So I'm going to have my common denominator of 15. So now how did I go from 3 to 15? By 5. So 1 times 5 gives us 5. 5 times 3 gives us 15. So 3 times 3 gives us 9. Well, again, just like in the previous problem, I've got 5/15 and I'm trying to take away 9/15. I can't do that. So I borrow from the 7. So it becomes a 6. Now, like I said in the previous problem, the trick is to find our new numerator is we just add our two numbers together, our numerator and our denominator together, and that will give us our new numerator. So back in this problem, if you'll notice, when I borrow from the 7, the fraction, to get this new numerator here, I'm going to add these two numbers together. Because what I borrowed from the 7 was 1. and it needs to have a 15 on the bottom, so it'll have a 15 on the top. Okay, so the 1 is 15 over 15, and then I have to add the 5/15ths to it, which actually gives us 20 over 15. But now this fraction is large enough that I can subtract this one from it. So 20 take away 9 is 11 over our original 15, our common denominator. And then 6 take away 4 gives us 2. And that's how you subtract with borrowing. Let's try one more, and then we'll be finished. So 12 3/8 minus 7 3/4. So 12 3/8 minus 7 3/4. Okay. First, rewrite so we can find our common denominator. And this time, the 8 and the 4, the first number they have in common is an 8. So this first one, I leave it alone because I didn't do anything to the denominator. The second one, I have a 4, so I multiplied it by 2 to get 8. So 3 times 2 gives us 6. Okay, so I can't do 3/8 take away 6/8. So I borrow from the 12. It becomes an 11. Our new numerator, and we'll take the 8 and the 3, add them together. So 8, 9, 10, 11. Back over the 8. Now this fraction's big enough I can subtract 6/8 from it. So 11 take away 6 gives us 5 over 8. And then 11 take away 7 gives us 4. So we end up with 4 and 5/8 is our final answer. So I hope this helps with subtracting mixed numbers with borrowing.